In this lecture, we will study the dimension and the constraint tools. So constraints are essentially applied rules to geometries that cannot be broken. They restrict how these geometries can move or change relative to each other. Overall, they help us to ensure that our sketch maintains certain relationships when being modified, which allows us to design with precision while maintaining fully constrained sketches. So in this lecture, I will demonstrate applications for both linear and angular tolerances, and then each of the common constraints. We will be using these on many occasions when sketching in this course, and particularly during the examples that I give, the assignments for you, and also the projects that we work on together. So let's jump into Fusion and start off with the linear and angular dimensions. So the shortcut for this is D on the keyboard, and then if we come up here, we've got sketch dimension, or if we hit create, we've got sketch dimension just down here. So I typically use the shortcut D on the keyboard. Now let's take a look at this line here. So this line is sitting at an angle from this one, which isn't yet defined. Therefore, it's free to roam in terms of angle. And if we see there, it's free to change its length. So if we want to constrain this, we can use the dimension tool. So I'm going to select this line to dimension. And then I've got two options from here. Number one, I can state its linear length like so, or I can define a length from the endpoint of the line just here to the origin. And so how I change between the two is just by dragging the mouse up. So if I drag the mouse closer to the line, it will recognize that I want to input a flat linear dimension, whereas if I drag the mouse up, it's then referencing from the endpoint to the origin. So let's say, for example, I want to input a dimension of 100 mil, just a linear length of that line. Press enter. Okay, I come out the dimension tool. Now we've applied a dimension to it, but as we can see, the line is still blue. And that's because we haven't defined an angle or given this a constraint yet. So in this case, I'm going to apply an angle. So an angular dimension, very simply, we click one line, click another, and then we see the angular dimension forms. I'm going to drop that there and give that an angle of 30 degrees. Press enter on the keyboard. And as we can see now, all of the geometries here are black in color, so they are fully constrained. So nothing can move. I cannot change the angle of this line or change the length of this line without coming into the dimension itself. So if I double click, hit 45, or if I double click here, hit 50, that's the only way we can change it. I hit Control Z on the keyboard to revert back. Another example I'll give is dimensioning between 2 points. For example, we have the center point of this circle. I'm going to left click here once, and the center point of this circle, which is here, left click again, and then we can just define that dimension there. So let's say 100. Now that's fully constrained. And again, once that dimension is in place, quite simply double click and we can alter it as we need. So that's the dimension tool. It's very straightforward and very commonly used. Let's move on now to constraints. So the first constraint we're going to be working with is the vertical and horizontal constraints. So to help me demonstrate this, I have two lines here. You can see neither of them are either vertical or horizontal. We can make some changes here. So if we come up to the top where our constraints are, we can see the shortcut for this is just here, horizontal/vertical, or we can select the drop down and it's available for us here. So we'll left click that once. Now we are in the vertical horizontal constraint. We can then left click, for example, on this line here, and it will apply that constraint to this line. And we'll see the symbol form here. Now this is the vertical constraint symbol, which indicates that this line is constrained vertically like we've just done. And I'm going to do the same for this line, like so. And I'm going to exit that tool by right clicking and then selecting OK. And we can see now that both of these lines have that constraint in place there. Now, if we have a line, for example, let's say at this angle, and we use the vertical horizontal constraint, in this instance, this line here will become horizontal. So if I left click, we then see the horizontal constraint. And the reason for that depends on the angle. If the line is closer to a vertical position, it will be assigned the vertical constraint, whereas if it's closer to the horizontal position, it will be assigned the horizontal constraint. I'll just move this out the way, and then I'll show you another example of where the horizontal constraint can be useful. So if I select the vertical horizontal constraint here, and I select this endpoint here, and then this one, we'll notice that this endpoint is now horizontal with this one here. And if we hover our mouse, let me just bring these closer. If we hover our mouse over this constraint, we'll see that this one is also highlighted and vice versa. And that indicates that that relationship is in there between these 2 points here. They are constrained horizontally. So this line here is now fully constrained, and the only movement we have in this line here is from side to side. We cannot change its angle because of this constraint, and we cannot move it up and down because of this constraint here. So the only thing left to do here is to press D on the keyboard and give a dimension between these two. Let's say 40. And now this line and its endpoints are in black color, and this sketch here is fully constrained. Let's move on now to the coincident constraint. So a coincident constraint is when 2 points are made coincident with each other. For example, let's have a look at this circle here and this line here. Let's come up and select the coincident constraint, which is just here, or on the drop down, it's the second one in. And here, as an example, I'm going to select the center point of this circle, and then I'm going to choose the midpoint of this line. Now I could choose the endpoints as well, but for now I'll just go with the midpoint. And we can see here, this symbol is the coincident constraint symbol, identifying that the 2 points here are coincident. So we can remove any constraint that we have applied. For example, if I right click on this one and I select delete, and I try and move my circle, we can see that that constraint is no longer in place. And to put it back, center point to midpoint. Another example I give is these 2 lines here. So when I've drawn these 2 lines, notice here that they are automatically inserted with, in this case, a horizontal constraint, and in this case, a vertical constraint. So if I just select the line tool and I begin to draw a line vertically, we can see in blue just there, just below the mouse, that Fusion will automatically apply that vertical constraint. And likewise, if I apply a horizontal constraint, we can see the symbol appear there. And that's really helpful when it comes to quick sketching. So let's select the coincident constraint once again. And in this case, I'm going to select this point and this point here. And we'll see that they are now joined. And if we zoom in, hover the mouse over the corner, we can see that constraint there. Let's now take a look at the tangent constraint. So in the center here, I have a circle and then 3 lines surrounding it. Let's say that we wanted this line to be tangential to the circle, like so. First of all, I'm going to apply a coincident constraint between the endpoint of this line, and then I'm going to select the circle here. And then for tangency, I'm just going to select tangent here, or in the drop down, it's the 3rd one down, and select the entire line and the circle, and we'll now see that tangent constraint is put in place, and we've got our line there. I'll press Ctrl Z, and I'll show you another example with this line here. So again, tangent constraint, select this line, select this circle, and now those two have this tangential relationship. So with this line, it can still move up and down, and it will always maintain that relationship with the circle. I'll give one more demonstration with this line here. So tangent this line to this circle. And again, lines can be at any angle. So for example, this angle is not lined. So if I move it around, you will see that it will always follow that tangency. And then if I go ahead and apply a horizontal constraint to this line here, okay, we can move it side to side like so. And then if I apply a coincident constraint between this point here and the circle, it's now fixed in place. And likewise, I'll do the same for the vertical line. Let's go for this point and the circle. And let's do the 30mm length line as well. Endpoint to line, tangency, line, circle. Now we have those 3 tangent constraints in place. It's a very simple tool to use. We use this very regularly when we're working with arcs or circles. Next, let's take a look at the equal constraint. So I'm going to demonstrate this on this line here and this one here. An equal constraint ensures that 2 geometries are exactly the same, either in length or it could be a radius or a diameter. So the equal constraint is just up here, or in the constraints, 4th one down. I'm going to select this line here, which is dimensioned at 30mm, and then select this one here. And now that relationship's in place. If I measure this line, we can see that it's 30mm in length following this one. And now that that relationship is in place, if I change this dimension, let's say change to 50, you'll see that this dimension will change also. Here we have 50mm and 50mm. And likewise, if I do the same for, let's say, this line and this line, although there's not a dimension in place, they will still have this equal constraint here. And if I go ahead and then apply a dimension here, let's go for 40mm, you'll see they are both 40mm in height. I'll demonstrate the same using some circles. So if I draw a circle out, let's say 40 mil, I draw another circle out, but don't place the dimension. Choose the equal constraint and select them in any order. So I select these two here. This one will jump up to the same diameter, and then we can change that, let's say 75. And now we have two 75 diameter circles. Next up, we have the parallel constraint. So put simply, this constraint ensures that two lines are parallel to one another. It's located just up here, and then the constraints, it's the fifth one down. So we'll select that tool. And to demonstrate this, I'm going to choose this line here, and I want that to have a parallel constraint with this line here. So if I left click there, we can then see that we've got that parallel constraint in place there. Where I move this line, it will stay parallel with this one. And if I change this one's angle, we can see this angle will change also, as they are kept with that parallel relationship. I'll demonstrate that again up here. So up here we have a rectangle and a straight line. I'm going to use the parallel tool, select the line, and I'm going to use, for example, this edge here. And then we can see that both of those are parallel to one another, and I cannot change the angle. So if I grab the end point of the line, not possible to change the angle. Next is the perpendicular constraint. So if I select the perpendicular constraint just up here, there's the sixth one down, perpendicular, and I want to have a perpendicular constraint between this line and this line here. So that essentially forms a 90-degree angle between these two. If I left click this line and then left click this line, we'll see the constraint symbol appear here, and we've got that 90-degree relationship. And likewise, I could repeat that for these two lines here and form the same relationship, 1, 2, and then we see the symbol appear here as well. Another example is if we press L on the keyboard, so we're in the line tool, and then we snap on to this line here, so I'll left click once. If I draw a line vertically upwards, like so, and then left click again, come out of that line tool, we can see at the bottom here that Fusion has automatically input the perpendicular constraint. It's recognized that this is coming off perpendicularly from this line. So again, it's quite useful for efficient sketching. Next, we have the fix/unfix constraint. So right now, within this sketch that I've drawn here, it is almost fully defined. There is only one piece of movement that this can do. So I hold on to a corner point, I can move this sketch around, but aside from that, I cannot alter any dimension of either the straight lines or the arc. Everything here is either fixed by the dimensions or by the constraints. So if I want to prevent this movement, we use the fix constraint. If I select this, I can then apply that at any point on this sketch, and it will then be fully constrained. So every line now is currently blue due to that freedom of movement. But if I apply a fixed constraint, let's say this corner point here, we'll see that every line now turns black and that this is fully constrained. So I cannot move this if I try and hold down the left mouse button. Everything there is fully constrained as a result of applying that fixed constraint. If we want to remove that fixed constraint, we need to right click on it and then come down here and select unfix. And then doing so, the sketch is blue again and I have freedom to move it. I could apply it in a different location, let's say there. So that's a really handy tool, and especially when perhaps we're not referencing sketches from the origin. Next is the midpoint constraint. So this is located by the triangle up here that identifies the midpoint. So with this constraint, if I then select, let's say this endpoint here. So of this blue line, I want this endpoint to be constrained with the midpoint of this line, which is roughly around here. So now I've selected that endpoint. If I just click anywhere on this straight line, Fusion will pick up where the midpoint is, and it will form a constraint between the two. And we can see that relationship triangle just in place there. Another example I give is if we want the midpoint of this line here to be constrained to the midpoint of this line here, we can just select the two lines. So for example, I'll left click once here, and then once again here, and we'll see that both those midpoints are now constrained together as represented by the triangle there. Another example I'll give is, let's say we have an example of a circle and a line. If we want the center point of this circle to be in contact with the midpoint of this line, just going to select the center, just going to click anywhere on this line, let's say here, and then we've got that constraint put in place. We've got our triangle appearing there. Next, we have the concentric constraint. So this is very straightforward. This is represented by the two circles here, and is also just down here below midpoint. So if I select this, and we want to have these two circles to be concentric with one another, i.e. their center point axis is concentric, we can just quite simply left click on both of those circles. And as you'll see there, we've got the concentric constraint symbol showing up, and both of these circles have the same center point. That can also be applicable on an arc as well. So in this case, an arc and a circle. If I select the circle and then select the arc, so this here is the midpoint of the arc. So essentially what will happen is the center point of the circle will be on the center point of the arc. So I'll left click on the arc, and then we can see that relationship put in place. If I try and move these around, we can see they move together because they have the same center points. Exactly the same for the circles as well. Next is the collinear constraint. So let's say, for example, here, I want this line here to be collinear with this one. So it will be something like that. We could raise this one up, something like that. We can come up to the top when we've got collinear, can select that. And quite simply, we'll just select the two lines to have that relationship. We'll see the collinear constraint symbol just there. And then if I adjust, let's say the height of this line here, so press D on the keyboard, add a dimension in, let's go for 50 mil. You will see that the relationship is maintained between the two. And likewise, if I adjust that to, let's say, 80, these two lines will always remain collinear with one another. And another example, if I hit L on the keyboard, and I start at the midpoint of this line here. So left click once, I just bring that across. And then I'll press L on the keyboard again, I'll draw in another line here. If I want these two to be collinear, I'll select the constraint. Now this line here is perpendicular to this line as indicated by this constraint here, and it's also this endpoint of the line is snapped on to the midpoint of this line. Therefore only this line can move to be collinear with this one. So if I select these two, we'll see this one jump down again to the midpoint of this position, and we're maintaining that collinear relationship between the two. And last but not least is the symmetry constraint. So quite simply, this just ensures that two entities are symmetric about a symmetry line. So in this case, this vertical line is going to act as the symmetry line, and we're going to add a symmetry constraint between these two 100 mil length lines. So that's located just up here. Click on symmetry. First of all, we need to define the very first sketch entity. So I'll select this one, and the second one, we'll select this one, and then our third click defines the symmetry line. In this case, I'll select the vertical line. What we'll see is the angle between the two is then the same. I right click OK. Now, if I adjust one of these lines, like the angle, like so, we'll see that based on its symmetry constraint about this line, that this angle will move as well. So let me hit D on the keyboard and dimension these two. Let's go for 45. We'll see both these angles are now 45. If I adjust that, let's go for 15. Both of these are now 15, and these lines maintain this symmetry constraint just here. So that is an overview of the dimension and the constraint tools. Now the constraint tools, I've gone through the most common ones, and we will be using these throughout the remainder of this course, and especially when we move on to the projects, the examples, and the assignments, and you'll become more and more familiar with them. It does take some time, and in my experience, the more that you sketch, the more you become accustomed to constraints and how useful they are in forming precision engineered sketches. So I look forward to seeing you in the next lecture.